All right, welcome back to Awkward Science, easily the most awkward science lesson that you have going on today. We are going to talk about magnetism from electric currents in this episode. And let's just suppose for a moment that you are going on a cross country car ride with a couple of friends, and one friend starts bragging about how he built a motor by attaching a shaft to the core of a galvanometer and removing the spring. Do you believe this, friend? Can this motor rotate through a full rotation? How do you know? All right, I'm sure you got some ideas already, but personally, I find this to be a little bit complicated. There are so many big words and ideas in this that it would probably help if we start breaking this down and looking for some meaning. So let's start. First off, let's take a look at a galvanometer. What is a galvanometer and how does it work? Well, basically, a galvanometer is a simple device that allows us to measure a weak current or voltage. So the picture that you see there is kind of a standard galvanometer. It's got two leads on it. You hook up your wires to each of those leads so that the current can pass through. And then the meter is going to show you how strong that current is. Now, what are the parts of a galvanometer? Well, there's a metal coil suspended around a piece of metal that is then suspended between the poles of a permanent magnet. As you can see, the core of that piece of metal with the coil on it has a pointer sticking out of it and a spring on it. As an electric current goes through the coil, it causes a magnetic force or field to exist in that coil. That magnetic field creates a magnetic force against the permanent magnet and actually causes the coil to rotate, start to turn. It's kind of held in check by that spring, but still it's going to turn somewhat, and that's going to cause the pointer to move so that you can get a reading on the meter of how strong the current is. So I mentioned the spring there, and that's part of our question. We'll come back to that in a moment and kind of think about what the role of that spring is. Let's look at the second part of that. What's a motor? Well, you've probably heard of a motor. We know that motors kind of do things. An electric motor can be used to turn stuff. Well, what really is a motor and how is it similar to and different than a galvanometer? Well, here's an animation of a fairly simple motor. A motor has a lot of the same parts. We see on the outside ring, we have a permanent motor magnet with north and south poles. On the inside, we again have a piece of metal suspended between the poles of that magnet with a coil wrapped around the metal. A current is being run through the coil, and as the current moves through the coil, it magnetizes the piece of metal on the inside. That causes it to have a magnetic field. When that magnetic field acts against the magnetic field of the outer magnet, a force is created and it causes that inner magnet to start turning. You notice on this motor, though, the inner ring is moving freely. It keeps spinning around and around. So imagine if we added a shaft or extended the shaft of that inner core. As it turns, it could be used to turn a fan blade or some other kind of turbine or the wheel of a toy. It could do some mechanical work. All right, so what are the similarities and differences there then between the two devices, and what is the role of the spring? What did that have to do with anything? So could removing the spring from the galvanometer allow the centerpiece to turn freely and act the same way that a motor does? Well, the short answer is no, it can't. And the key is that if we look at the motor, notice the little kind of goldish brown part on the core, the two kind of semicircular pieces of metal that are turning with the rod on the inside. That's called a commutator. What the commutator does basically is that the current is coming in through those two lines at the top and bottom into that center piece. The commutator actually changes the direction of the current as it goes into that inner magnet every half turn. So now look a little bit more carefully at that inner magnet. Notice how the colors keep changing as it turns. They aren't staying the same, they're changing. That's because the direction of the current keeps changing. As the direction of the current changes, it changes the poles of that inner magnet. And that means that the inner magnet is always going to have a repulsive force. So as the blue part comes around to the red part, it then changes to red because the current is changing. So the red is repelled by the red and forces it to keep turning in the circle. So the commutator is the key, not the spring. In the galvanometer, we could remove the spring, but without the commutator, the inner ring of the galvanometer would go halfway, and then the two poles would attract to each other. The inner and outer magnets would attract to one another and stop because the current isn't changing directions. So that is why in a galvanometer, it would not be able to rotate more than through a full turn, even if you were to remove the spring. So, about your friend. Yeah, well, choose your friends carefully, and until next time, keep it awkward.